Okay, so uh, yeah, there's a vile force of darkness awaiting me at the end of this save file. I've already tried to pay them off, but they've been here for quite a while and they're not leaving. I have my dwarves ready just in case. But yeah, 124 invaders. I paid them off. I'm sure. Well, I don't know. I didn't actually see a dwarf come out here and give them anything. I don't remember the name of the artifact either. Maybe it's assigned to a noble? Do I have to unassign it? Wow, that gem was worth a lot of money. Should actually just give it to him. But yeah, sure. Let's just give him. I'm never gonna trade this stuff, so I'll give it to somebody. Just want these guys to leave. My dwarves are sick of being on station. I've gotten attacked a few times, so they're like, they're pissed. I'm kind of running them ragged. Okay, what do you want? I've caused so many cave-ins. Oh yeah, this was Galena. Oh shit. They're attacking. Oh my god. Well, at least I had my guys out here. Could have been worse. Okay, so... Yeah, you might as well just send them all in. This is gonna be gruesome. Down to 3 frames per second. Not surprised. Nothing to do but watch the mayhem. Oh shit. What do I do? This is bad. This is really bad. This stupid lever never got linked. Oh, didn't notice that before. Okay, well, the goddamn ship commander got taken out. There. We're getting whittled down on dwarves here. And they're having... Yeah, the traders stopped coming, and now the dwarves stopped coming, so... Yeah. I don't know what to do here. Take 2 squads. Tell them to kill this guy, I guess. Okay, so whatever they got left is just ragtag. Just a matter of waiting. It's best to just wait for him to get here and come down the stairs and just slam him. Yeah, I don't even have that many dwarves here yet. Well, hopefully this does it. Oh, that's nice. Damn. Okay, the dwarves will finally get a rest. Well, it's still early spring. Hopefully some kind of traitor come. Man, 18 injured. That's pretty bad. Oh no. It breathes fire? Shit. This isn't good at all. This is not gonna be good. Should really shut down the farming. Okay, sweet pods, yeah, I don't need to grow those. Yeah, we'll just stop growing sweet pods for now. We have enough. Okay, I'm just gonna do this. I saw a whole bunch of crap that was off limits for some reason. Okay. Might as well keep marking stuff like that. Buggered. I'll be dead soon, I think. Especially if I keep being greedy, which I plan on being. Oop. Okay, so same deal as before. Wait until he gets close to the steps, then try to rush him. I don't really know any other strategy. Okay, we only have like 2 dudes here. This is not gonna go well. At all. This is gonna be a goddamn massacre. Well, here we go. Oh shit. Yeah, that's a lot of dead dwarves. Just getting attacked too much. I don't know what else to do. Probably gonna die here. frail. He might die quickly. That would be nice. Oh no, don't walk back into the fire. I don't know about this. I should probably tell them to stop attacking. Can't believe this one dwarf. Is fighting him like this. It's crazy. If this guy kills this thing, it's gonna be amazing. Come on, there's gotta be other dwarves that are gonna show up soon. Damn. Oh shit, where is he? Did he die? Did that monster actually die? It must have. Damn. No, you have to kill these two. Hopefully we have a little bit of time before something else attacks us. Because we got a lot of injuries. Okay. Already ran out of space here. Oop. Yeah, okay, there's where they... Where am I going to put the rest of these? If I just do that, what if I make this... Yeah, whatever. It's not that far. God damn it. Can't... One short sword, one buckler. things are improving. Just need plaster powder. What was the other thing we put down here? Was it sphalerite? I think so. Galena. It's here. Malachite, tetrahedrite. Oh. Damn, these smelters are all fucked now. Because they were all associated with certain things before. Wow. I'll be able to fix it. Oh yeah, monophyllite blocks. Crazy. Let's just use basalt then. Do I have a bunch of phyllite here? Not really, but let's make some anyway. We'll just do 10. Just cause. Yeah, our population is going down fast. I really hope some kind of trader shows up in summer. It's not surprising the elves don't like us. I feel like I should just make temples, stuff. Who's this guy? Yeah, whatever. Let's just do them all. Zon. I'm doing Vukar. Whatever. I don't care anymore. Yeah, this guy seems cool. should just be making dining halls wherever. Shouldn't I? Might. Oh shit. Oh shit. There's no one left. Oh shit. This is gonna get really bad really fast. Why are you stranded? Oh, he's getting... Oh, fuck. This guy's getting carried away by a bat. Can't believe he's not severely injured. Oh yeah. No. Expecting to encounter... Yeah. Oh shit. And now I'm screwed. Where the hell is... Oh my god, it's right there. Maybe he won't attack me right away, if I'm lucky. Because he's got to go around the lava, but that's not going to slow him down that much. Yeah, this is bad. Okay. Is this pretty much over too? No. No, it's not. Okay. One invader. It's right here. How did it get away? Okay, well. Okay. Here we go. Militia commander again. This was a fun fort, but I feel like it's gonna come to an end soon. Nothing is really getting done anymore. Oh shit. Gracious something or other was fighting. My military is in shambles. Erdem, Erdemir. actually saying? Is it actually trying to tell me that they're... Thing is... Thing is Tim or whatever the fuck. This is horrible. This is like pulling teeth. Dib. Okay. I took a screenshot of it and have it on my second screen so I don't have to keep going back. Okay. So we want... Zolban. There we go. Sazir. Kogan. Wait, did I do this guy? Okay, now let's fix... Babok and Rovod. There. Now let's run this again. got Bob. Bob. Cattle around. Lycott. What's this guy's name? Farmer. Nomo Lolo. Prison. Okay. Run this again. Inod. Kivish. Okay, that should be everything. Wow. Took long enough to fix that. But it's good that it's done now. Probably have... Okay. Okay, there's 2 people that could potentially be assigned, but I'm just not going to do that right now. I probably don't need as many hunters as I have. Just leave that alone. No conflicts. God damn it. New demand. Black bronze weapon rack. On the double. And another lead sarcophagus? No, it just didn't get made yet. Okay. I want to check this again. Oh. Okay, well hopefully they have that figured out by the time we get attacked again. Summer. Humans, maybe. Here's your black bronze. Hope you're happy. Why is the, like, super wounded guy? I guess he's been sutured up. Okay. Wow, there's actually mining going on? Crazy. Just unassigned a bunch of miners. Oh, that's actually quite a bit of hematite. Yeah, hopefully traders show up. If not, I don't know what I'm gonna do. Probably just fucked. Once the traders don't like you, you're boned. Okay. Because the thing is, if the traders aren't coming back, then I could just stop milling. No, but I can't because I want the dye. You can't change that about milling. Damn. But what I could do is just stop farming anything that can be milled. That's always an option. Dolphins? Yeah, okay, I already got that one. Down to 4 injured citizens, that's not bad. Yeah, you're gonna have to stay in the military. Same with you. I have to stay anyway. Sorry. Yeah, like nothing's getting done anymore. Yeah, if a necromancer comes back here, I'm fucked. Okay, good. No one's died in a while. That's nice. Midsummer. Oh man, the traders are not coming, are they? That sucks. We're dead in the water. Even though we had the queen and everything. Migrants. It's gonna say no migrants. There's no way. Yeah. Damn. We're dead. Suspend manager. Yeah. Nice. Okay, we got some more reptile spearmen. Let's go. Okay. Let them split up 2 and 2. That's what I wanted to do. Okay. Cavern dwellers. They're just chilling. Why is this guy like this? We should really just do them all. This might be a bad attack, you never know. I mean, most of them are now, because I've got too rich. Okay. Here we go. Fuck. Wow. Now we're... Okay, we gotta finish this off. Fucking traction benches. Why? I don't know what I'm gonna do with them. Can't even sell them because they're too goddamn heavy. Okay, we better... was easy. Oh, shit. Yeah, see, he just killed a dwarf. That's a fell mode. That's the evil one. This is the first time I've ever seen that, actually. Wonder what he's gonna make. Made a statue of that dwarf. Jesus Christ. That was the one, right? Yep. What if I did this? Needs flux boulders? Is that what I just saw? There's still some available. again. Mandated what? Short swords. Okay. 45 of them. It's not that bad. Sarcophagus.
And today on the bench is a pretty old Yamaha amplifier. It's late 70s, it's the P2201, should be 200 watts per channel. This one's only got the one channel though. And this was released in 1976 and was the first of Yamaha's professional series. It's got a big chunky professional power switch and 2 professional volume knobs, and it's missing some professional screws from its lid. It's a complete dog. Does look better at the back, mind you. Speaker terminals are in good condition, and it looks like it accepts most input cables. And how's this for a bit of honesty from the audio industry? The rated temperature limited output power is 12.5 watts. It was at least serviced by JD back in 1996, so I assume this happened more recently. Look at the state of that. And it wears its transistors on the outside because that's actually quite dangerous. I mean, seriously, the case is a collector. That could be like a positive and negative voltage rail on there. God knows how high that is. I think I need to proceed with caution. If you've come to watch a man get electrocuted, it's the wrong channel. Oh, apart from that one time. Before I connect it to the test equipment, I make sure the speaker terminals are wired the right way around, so I don't want to blow my scope up. So I want continuity there, and not there. Good. And continuity here. Oh. And that'll be a significant problem that needs the lid to come off. Well, this is clearly meant to be because half the screws are missing. But it's quite chunky in there, not much spare room. As far as big amps go, this is quite a simple design. Power supply in the middle and a mono channel either side. And viewed from the other side we can see a problem. Those speaker terminals have got wires on, unlike these. Furthermore, this channel seems to have more components. Yes, a suspicious lack of parts here. They've even unsoldered the input wires. Someone's clearly had a go at fixing it and given up. I wonder what horrors are in store. Oh, I think we've been burgled. And on the positive side, you can't get electrocuted off that bit. Or is that the positive side? I don't know. There's only one screw in here anyway. A rather chewed up one here. I think that's out now. It all looks a bit ropey to me, and there's more transistors missing here. Look at all that crusty stuff at the bottom. I think that was probably glue to hold these down, stop them vibrating. It's gone a bit nasty now. And the absence of 6 power resistors here tells me this thing's had a right bit of a blow up. With so many bits missing, it's a good idea to take the other channel off, use it as a reference, because it apparently works. See how much gives on these cables? Not too much. Unsolder these. And these. These have been undone before, I can tell. I haven't had to unwrap the wire. These might put up more of a fight. Cut that off to make a bit more room. Now these might be altogether trickier to get off. These are wrapped round, I can tell. There we go, there's one. There's still that thermal fuse that's holding on to this. I'm going to have to take the board off. I'm going to give this board a good clean before I start working on it. It's just a bit grim, really. This transistor's just waiting to get its legs ripped off, so I'm going to just take the screw out of that first. Spare its life. The transistor sockets are just held in with one screw. Bit of a wire bend to get at them. Just surveying what we've got, and in the back of this, well, there's some rather horrible soldering, and the solder mask's been damaged on here. Just the extent of the damage, I don't know, so it definitely needs a clean up. Before I throw it in the ultrasonic tank, I need to check for any components which won't like it. Any polystyrene is going to react with the cleaning chemicals I've got. So I think I've got 1, 2, 3. Yeah, it's only 3 on there to take out. Okay, there was 4 of them. And in the tank it goes. Oh, should see a bit deeper than that. Yeah, that basket should come out. It's too shallow. That's more like it. I'm going to give this one a clean as well, because I'm going to give it a bit of a service, even though it does work, apparently. Just take this off as well. This one actually has a plate on there, look. Huh. And I'll need to take these transistors out to get the sockets off. Hopefully they all fall out now. Most of them. Just got to pull them out now. That's easier said than done. A bit tight. Just pluck these out of the board. And this one's ready to go as well. Although I have noticed, look at this, cracked resistor there. Yeah, that'll need changing, I guess. Oh well, off it goes. Just chuck it in there. Go on, have a bath. The heat sinks are pretty manky too, and these insulators are sort of stuck on there. So once I can free them off in here, with a bit of a brush as well. Well, it definitely needs a clean. It's thick with dust. These bolts just have the look about them of being a bit tight. Yeah, they were. And that reveals a little bit more. Just untether this wire. Just unwrap that a bit. There's another one there wrapped around this cable. That's pretty tight, that is. See if I can unwind it. These ground wires are what's holding it on now. Got this flexible shaft, very good for these situations. I'll take this bottom cover off because it's not really doing anything. I could do the clean. Because a lot of these amps have spent some time in nightclubs, there's always blooming sticky residue. I think it's from the dry ice. You can only get it off with a bit of foam cleaner. So I'm taking these metal shields off. And more dust in here. Comes off easy enough though. I need to take this off so I can actually operate this switch. Held on with a little screw. It's going to be a little dust. Now I can operate it. Squirt a bit of contact cleaner in there. Get it all working. And on this side as well. Tip it on its side so the cleaning fluid runs down the switch. Just work it a bit. Admittedly, not much skill required for this. No, that's empty. Something different now. What's this? Electrolube. They're all the same, honestly I believe that. Well, I assume I'm going to fix this channel so that can come off. Oh, what a mess. That's quite sticky, so I'm going to try some label remover spray. Hopefully it doesn't do anything I don't want it to. I'll take all the writing off the panel, because that's never happened before, has it? Will it come off? You have to scrub it a bit, but yeah, it is getting there. I'm all done with cleaning it, and an advantage is it smells better, because to be honest, smell like the bottom of a Hoover bag. There's not many controls on the front, so I'm just going to check that they all work before I bolt this all up. Start with the main switch and check we've got nice 0 ohms across here. That looks good. And this one, perfect. Let's check this fuse as well. Also good. Just checking these pots work nicely. I'm going to put 10 volts across them. I've got the negative rail connected to ground here, so I don't have to mess around with scope probing. Probe the centre pin, which is the wiper. A little bit crunchy at the top. Oh, that's clearing up. Yeah, that's fine. Probably never dared to turn it up that much. What about this one? That's also a bit cracked at the top, but that's clearing up pretty quick. Look at that. Yeah, that's fine too. This is a particularly difficult screw to get in. Not quite well placed. So the bendy screwdriver comes to the rescue again. Trying to thread this through is a bit awkward. More awkward than the last one. It's got me out of trouble a few times, this old bendy. Now we've got this old metal wire wrapped around here. I wasn't sure what it was trying to achieve by doing this, but I'll make some vague attempt to put it back. Same here. Not really serving much purpose, but it's back on now anyway. Can put the bottom cover back on now. Don't need to get to the underneath anymore. Didn't have that many screws when it came in. Pretty sure there's no problems there, so this cover can go back on.
That was really bad.
Without that in it.
I'm gonna be dead soon.
Now I'm going to have a look at these amplifier boards. They've been cleaned, been dried in the oven, ready to work on. You'd have never guessed the board was glossy before it was cleaned, would you? Look at that. Just going to put these polystyrene film caps back in, so I'm not sure that they'll survive the cleaning process. Seems to have an excessively long leg there. Not now. I wouldn't normally change all the caps for the sake of it, but you know what? There's only 5 on here. And it keeps the capacitor police off my back as well. Hopefully these just pull out nicely because they were glued down originally. Looks like the ultrasonic cleaning's weakened that somewhat. Some of these old glues can be a problem in the future, so they can absorb moisture and cause all sorts of trouble. Like here, you've got components literally joined together by glue. If it doesn't conduct electricity, that's not a problem, but when it's this old, it's best to get rid of it. This glue here is not going to actually short anything together, but that's gone quite
I don't even...
crunchy. Look at that. Just clicks off. You can see how it's changed over the years. Probably new capacitors are a lot smaller, and I don't actually have actual leaded versions of this one, so I'm going to have to put a radial leaded one in. Sort of bend its legs over.
Well, we're going to get a lot of silk out of that.
Similar problems here. The lead spacing's quite far out.
Oh, I guess they entombed all those guys.
I would replace this 10 ohm resistor with a split down the middle. Yeah, this is part of the snubber on the output. Yeah, so it might see a bit of load. It looks to be soldered into a socket. See if it comes out. It all seems to be falling apart. Oh dear. Got the new resistor with the legs hopefully bent to the right position. See if I can get that in that little socket. Now I can put the sockets back into the heatsink. Bit of a fiddle. Little screw in there. One in there. And one in there. This side still had the cover plate on. Hadn't been disappeared like the other side. The thermal cutout switch sits there, and it's annoyingly it's covered up by the circuit board. A bit of a bad design really. We'll manage without it whilst we're testing it on the bench. Let's pop a couple of screws in. This base drive transistor, let's get the cable straight. It went under there. Bit of a fiddle. Let's put a bit of heatsink compound around this hole. I'm going to put a micro insulator on top. I can see where the hole's gone. Where has the hole gone? Oh, there it is. And a little bit more on top. Not much. Then just going to screw this right on top. I put some heatsink compound down here as well to sort of dot it around. It'll all spread out. Got some micro insulators here. Got the original transistors, there's nothing wrong with these. And put a few dabs of heatsink compound on there as well. Okay, I want to power this up with the bench supply first, so if there's anything wrong it doesn't blow up. So I need to know what the connections are. It just happens to be the schematics for this are quite easy to come by. Need to feed it with a positive and negative rail, about 80 volts. And there's another 13 volt AC output here. This is for the transistor bias. And this provides a floating power supply for these lower rail transistors. This supply gives me plus and minus 75 volts. About 0.2 amps I'll do. I make this negative by putting the common like this. Positive rail, ground rail, and a negative rail. Goes on there. Ground on there, terminal E, negative rail there. And this will replace our floating AC supply. It's not sense tap, so that's fine. One on there. Put our speaker outputs there, there's the ground. And that's the positive. Just plug that into the dummy load. Well, I think that's ready to go. Let's turn on this floating supply for the lower rails. Then on with the high voltage. Oh, that's not right. We've got a lot of DC offset there. Oh, look at the power supply. Like, no current on the lower rail and too much current on the high rail. Well, this was a working channel apparently, so I must have missed something. The ground on this amp's labelled terminal E. There's also an E terminal by the input. And I have notes on the schematic, the ground here only goes to this terminal E. And there's no internal connection to this one here. So it must rely on the wiring inside the amp to make that connection. So I'll just try a crock clip on there to make a direct link. Ah, that's made no difference at all. Let's try giving it a bit more current. And that's helping a bit. Still not right. What if I reset the supply? See if it works now. There we go. It looks quite nicely balanced now. Obviously need a bit more sort of oomph than I had given it. So I'm going to wind this up to the same sort of current, see if it starts up nicely. Bit twitchy. Perfect. Just going to check the bias current with these test pins. It's supposed to be 10 millivolts. That's nearly double. Let's knock it back a bit. A bit much. I'm going to put a test signal in here. Might as well see it run. Well, that's looking okay to me, so that can go back in the amp. Let's not forget this one. First thing we need to put on, because the wires are a bit short, and it's this thermal fuse, and I think this board's got to come out as well. Just add a bit of the obligatory heatsink goop on there. And I'll try my best not to get it on my fingers. Now I can pop the board back on. Bit awkward to get these wires in. Try and hook it down there so I can solder it. And now the black wire. Now the negative supply. I'm going to tin these a lot. Get lots of solder on. And make it a lot easier to solder these on. That works so well there. I'll do it again here. That's the easy one done. Now for the left channel. And this is also cleaned up very nicely in the ultrasonic cleaner. Very pleased with that. I'm going to start off by putting these polystyrene film caps back in. So we took them out before we cleaned it. Start with a 560 picofarad cap here. Then a 470 picofarad cap here. 47 picofarads in there. And 100 puff here. Just spotted a very clean looking dry joint there. If I push that, I can see the leg moving. I don't know if the ultrasonic cleaner caused that, but it probably didn't help. Next job is replace these 5 electrolytics. Put our nice new ones in. 470 mic these are. $100 microfarad at the bottom. And finally our 220 microfarad one across here. Tip those off there. Because the main power transistors are missing out of this amplifier, also these 2 drivers here, we have to think something pretty nasty happened around here, so we need to check out all of these components, make sure there's no further damage. I'll start with these fusible resistors, these white ones, because they're designed to blow. Start with this one, 22 ohms, this one's okay. A 390 ohm one here, that's okay. 120 ohms, yep. 470 ohms, yep. 220, okay. Another 220, good. And finally 68 ohms, perfect. Now the emitter resistors have been removed off the board, we'll check the bases. That one's okay. So is that one. Good. Okay. Same here. Good. Check out this transistor that lives on the heatsink. There's the base collector. That's good. And the emitter. Yeah, that's not short, and that's measuring the 22 ohm resistor. Check transistor 13, sneaking down here. That's okay. And so is that. Any shorts there? Nope. Then transistor 14. That's okay. Okay. Check for shorts. Nope. Transistor 13. Okay. So this is okay, these are okay, these are missing, that one's okay. Just need to check these 2 out, then I'll be happy. There's transistor 8. Okay. No shorts. Good. And here's transistor 9 onto the base. The collector. Good. Emitter. No shorts. Okay. Well, the repair abandoner did at least identify all of the blown parts. Credit for that. So why did they give up? And that was very likely down to the scarcity of these original parts. These transistors are long out of production. Looking for a 2SD381, 2SB536, and a set of reasonably matching 2SC1586s and 2SA909s. You have to be careful when buying replacement transistors, because if they're old and vintage, they're very unlikely to be made recently. In fact, the ones for sale, they call themselves new old stock, most likely fake. And I'll show you what I mean by fake. This is a genuine transistor, rated for about 10 amps. Look at the size of that silicon die there. Nice and chunky. And this is what turned up from China. Had the exact same markings on. Clearly not the same. So after getting my finger stung more times than Pooh Bear, I decided I only fit modern transistors. 2SD381's an NPN transistor. 120 volts collector to emitter, 1500 milliamps collector current, and a gain of at least 40. And the 2SB356 is a pretty similar complementary pair, PNP, only 110 volts collector to emitter on this one, 2 amps collector current, and gain 40 minimum, same again. I think the MGE 15028 and 029 are the perfect match. The collector emitter voltage, 120 volts, that's just the same. We got a lot more collector current, 8 amps, these are a lot stronger. If we have a look at the DC current gain here, 40 minimum, perfect. And we got our 2SC 1586 NPN, 200 volts, 15 amps collector current, and a gain of 30 or more. And the 2SA 909, the PNP complementary, I suppose, 200 volts, that's the same, 15 amps, and a gain of 30 minimum. It's a similar story for the power transistors, only it's more important because the high powered ones are more likely to be faked and blow up. The collector emitter voltage here, 200 volts, the same as the other ones. Collector current, 16 amps, actually slightly better. And the current gain, somewhere between 15 and 60. I think that's going to be close enough. And here are the brand new parts. These have come from Farnell. I quite like RS components because they give me free shipping. I've never got any bloody stock though. These boxes are rather nice, aren't they? Look at that. The parts inside, that's all. Yes. Oh, must have bought a spare. There we go. These transistors have got to sit in here, fasten this heatsink, but rather than trying to get my screwdriver in, I'm just going to unscrew them. Just going to put a little bit of heatsink compound on there. Doesn't need much. Just lay the transistors on. Of course I've had to get new screws as well, because they were also burgled. Watch this torque over when I do it up. Very annoying. So transistor 12 is our PNP transistor. Goes there. And transistor 11 is the NPN one. Just put the first screw in loosely so I can line the second one up. Now I can do this one up tightly and nip that first one back up. Got the new emitter resistors, 5 watts, 0.47 ohms each. Just feed them into these holes. I'll actually clean these out. I didn't film it, it's very naughty of me. But you didn't miss a lot. Just a few minutes with the solder sucker. Time to mount it on the heatsink now. It's all nice and clean as well. To make sure I've got this the right way round, this transistor's got to go onto there, and these holes are exposed on this side, that's good. So these transistor bases need to just line up in those holes. Now we don't have the shields put on here, but I don't think it's too much of a problem. There's quite a gap between there and the board. It's not going to short out. So we'll attach this transistor onto the heatsink first. I'll put a bit of heatsink compound on. And then pop a nice new mica pad over it. And a bit more heatsink compound on the top. Although I think those are going to be pretty flat. So just get this lined up as close as I can. And somehow guide my screw right through all of the holes, hoping it finds its way. Yes. Just torqued up a bit there. There we go. Pop a couple of screws in. Now ready to flip this over and put the power transistors in. More heatsink goop around here. Let's pop the mica insulators on. I hope to just drop them on. Don't want to touch that goop too much if I don't have to. Then a bit more goop on top. And here's our new output transistors. A bit more awkward to open. Tape on these. See if we can just drop these in without getting covered in heatsink compound. There's one. And there's three. Now for the PNP ones. Wiggle the legs a little bit. There we are. I've even had to get more fasteners for this thing. They'd nicked everything. Just got to test it now. Start with the speaker terminals. Put these crop clips on. And our negative supply, ground, and positive supply. And our floating 12 volts on here. Let's not forget to ground the input. We know that's a problem. Fingers crossed. On with the floating supply. Now the main supply. Oh, this looks pretty promising. As does that. Not much DC offset there, if any at all. Let's measure the bias on this. See how it's working with these transistors in. Well, it's a little high. Needs to come down a bit. We're looking for 10 millivolts. The bias current will probably continue to drift upwards whilst it's warming up. It's best to adjust it once it's warmed up and when it's in the actual amplifier where it's got the full power supply connected. Just connecting an input signal to this, just to see if we're getting a proper waveform come out of it. And it does. There's nothing wrong with that. So I reckon that's ready to go back in the amp. Put some heatsink compound on here for the thermal switch. Fold the board back over for the last time. just connect B plus. Bit awkward. There's a lot of solder on here, so it'll just melt on, I hope. Now the ground. And then B minus. Now the floating supply. Let's get the signal cables on. This is the ground. It's rather hot, that was. And there's a signal. Okay. Let's tin the speaker terminals again, just with all fresh solder on there, and also preheat them. Same with this one. I should be able to solder this on now. Now to deal with this manky cable, there's nothing to do but replace it. Just undo these terminals. I'm recycling an old power cable here. It's actually in really nice condition and has a moulded plug. There, looks quite posh. Feed the cable through the gland. There we are. These wires need to be a fair bit shorter. Just going to chop them off there. And just bare the ends off. I'm going to tin the tips of these wires, stop them fraying. It's time to test it. I want both of these channels on, and some test leads in here. That's for the one channel, and this is for channel 2. I'm going to clip these on the back of the speaker terminals because they're just easy to get at. Make sure you don't get the ground on the wrong terminal. That's how you blow amps up. And put a new cable in the test socket. And this will power the amp with some light bulbs in series. Bit of inrush current there, but it seems to have settled nicely. No silliness on the speaker outputs. That's a good thing. Just want to monitor the bias of these boards whilst it's in situ. Onto the CT terminal. And PE. So channel A and channel B. We'll just leave that to warm up for a while, see if we get the 10 millivolts that we're expecting. But in the meantime, I've got a bit of news for you. I moved to a new workshop. So this is the last video you'll see in here. They both drifted above the 10 millivolts we're looking for by about the same amount really. Just going to tune them down a bit. I think that'll do. Take these test leads off now. Let's give it an input signal. Those look nice healthy outputs. Let's compare the amplitudes. Yeah, they're pretty tightly matched, they are. just going to connect one channel into the analyzer, see if it's getting the output it should. Although I can't remember, they make it display the power. There we go, 19.0 for power into 8 ohms. 19.0. Now you're going to power it on. I'm going to back these off before I increase the input signal, see if I can get the max out of this thing. And I think we need 2 volts. I'm going to back these off as well, because 200 watts into 8 ohms needs 40 volts RMS. Let's switch channels on here, put the analyzer on the B channel. And now both channels together. So channel A all the way to 200 watts. Now channel B. There we go, the amp is running flat out. Can't do that all the time, mind you. Remember, 12.5 watts. Well, it's passed the full load test with flying colours, so I'm going to put the lid on. Although some of these scratches on, it actually looks better upside down. It's looking nice and tidy now. Just one problem, these transistors are still exposed, and that's a bit of a safety hazard. I measure from there to there, nearly 160 volts. I can't have this leave the workshop in that state, so I need to make new covers. I have found one of these for sale on eBay, about 15 quid. It's a bit steep for one cover, and he's only got the one. That's no good to me, but it's given me some ideas for the design. But I don't think I'm going to put slots in it, because that's going to be quite difficult to do. I might go with the round hole design. And here's my version of the covers. I'm going to use round holes. I'm just going to drill in there, a lot easier than putting slots in. And I've also allowed for a bit of stretch when you do the bends. You have to watch for that. These things grow when you bend them. But this will at least make use of this scrap steel I've had lying around for many years. With the black paint on, these look quite professional, but they are missing something. The originals had a warning message on there telling you not to remove them. I think it'd be a very good idea if I put the same warning on these replacements. And this will be making them on my favourite label printing machine, the CPM 100H. It's very much a professional printer, and I don't use it for conventional uses, but I have to say their technical support is brilliant. It's actually a thermal ribbon print, and it has the limitation that it only prints solid colours. And some of the ribbons are a little bit translucent, which can be a problem when you're printing on black. But I found a way of getting it to print layers, which gives me quite a large palette. To make this colour grid, I printed all the same colour squares going all the way across there first. Then on top of that, I printed them again over here. You can see all these different shades that are available. And all the lettering on here is a slightly yellowy cream colour, and the closest I can do here, I think, is this. So I need to print the gold on top of white. That will do it. So I'll load the white ribbon first. Now I've just got to design a label. You can make most labels in the printer's own software, but I personally prefer using Visio for the design, mainly because I use it for the other designs I use where all the measurements are scaled up, so it makes sense just to draw the labels in the same package. So just grab hold of the text off here, copy it, just paste it in the printer software. In fact, I want 4 of them for the 4 covers. It'll also cut the labels out if you tell it what shape they are. And pretty much all of my labels are rectangles, so there we go. So just drag it over here. Just neaten it up a bit. And then you just set it to be a cut shape, showing this little dagger icon. But it's also going to print this rectangle, so we need to get rid of that. It's easy done by just going to the line attributes and say none. The next step is to set a colour of this Visio object. Although it looks black, it could be anything. Because I'm using solid colour ribbons, I'm going to choose those, and I'll set this to be white. Now if I tell that to print now, I just get 4 labels with white writing on, but I want to put gold on top of the white, and this printer software doesn't actually want to do that. So what I need to do is put another object in here that's going to trip the printer up. Something like a simple line. And just plonk it right at the top. Doesn't matter where it is really, just not where the labels are. And the trick here is to give it a different colour. I'm going to go with this, because I don't use that one at all. Now I can just simply tell it to print. It's giving me the option here if I want to print several hundred or whatever. Just the one will do, thank you. Now it's asking me to put the other colour ribbon in, but we're going to say no thanks. Stop there. Now I'm going to select these text objects and change their colour. Custom colour 2, or whatever colour you want them. And I also don't need this here anymore. Now we can open this up. Let's pull the white cartridge out and put this gold one back in. Then we just click print again. Well, that hasn't taken too long at all, and the best bit is it's put them all out for me. Well, that's the full set there. I'm quite pleased with those. Let's see how well they fit. This old Yamaha's still a bit dinged and dented around the edges, but it's better looking than it was. It now works in stereo and not as dangerous. Catch you next time. And today on the bench is a Crown XLS 5000 PA amp. It's in pretty bad shape, partly from how ships in a cardboard box with the integrity of a plastic bag. And I'm not going to lie, this one's an absolute dog. It's quite bashed and bent. It's even got tape holding the front panel on, and there's a lot of screws missing. Panel's held in with a bit of masking tape. It's not a pretty sight. It's even been away for repair somewhere else where they've carried out no work. But at least at the back everything seems to be there. Oh, apart from the screws, of course. These side plates are all bent from transit, although 28 kilograms is going to bend anything. I can definitely say it's had a hard life. And it's that powerful it needs a 20 amp IEC connector. Wow. Well, I'm not sure the 5000 watt rating's real because it only needs 2000 watts putting into it. Well, I'm not powering this up until I've had the lid off. Let's see what's going on. I'm not sure what sort of screw that is. It's not quite anything. Well, luckily, it's sort of coming out. Well, this one is a Phillips head, although it doesn't match the other screw. And that one's a Torx drive. Off with the lid. Well, I know an abandoned repair when I see one. And a helpful message inside off the last technicians. Lower modules all blown. Oh no, this is going to be expensive. It's not even fastened down. More useful info here. Some IRF 1407's gone. These will be little TO220 devices. So 4 diodes, 4 FETs, 12 TO247s. 12. Shame someone's nicked 2 of them. Well, as it's already disconnected, I might as well unplug these so I can get the module out of the chassis. Oh, is that not a plug? Oh, it's not a plug. How annoying. Well, the cable's plugged into here, so I'll move this insulation out of the way. Oh, even these are glued in. Oh, blimey. Be easy just to unscrew these, which I think is what they did anyway. Can this be lifted away now? Oh, no, there's still a cable. That's cleared a bit of room, but it's still like spaghetti in here. Doesn't say on here, but I think these transformers must be 1000 VA each, easily. And they're probably 10 kilograms each. Big chunk of the weight of this. A few other little boards kicking around. You've got 3 bridge rectifiers here, and another 3 on this side. And in the middle here, some sort of power management board. Not fully sure of its function. It's got 2 big chunky relays on there. Some little bridge rectifiers. So it's probably generating the low voltage supply and probably handling the inrush current. And that leaves this mysterious front panel board with the pots and the LEDs on. I'm not sure how it was fixed in. There's no screw holes. I'm sure it wasn't always this masking tape. Well, I think the cooling fan's free to turn. It's probably okay, that bit. Well, there's only 2 screws holding this in. Won't take long to take out. Well, there we go. Well, there's a part missing here. That'll be the inrush protection. That's obviously blown up. And this arrangement doesn't exactly look factory original either. Yeah, this amp's had trouble. Well, I don't think they're the original pots. That explains the mystery of how this is stuck in. I think these would have been threaded originally. Oh, what a mess. Take I'm not the first person in here. So taking on a job like this, you really want a service manual. I had a look online and couldn't find one for this Crown amp, but luckily I understand it's very similar to a Phonic XP5000. That's handy. I'm going to start off by making sure these things work, what's left in this chassis. We can see in the service manual there's actually 3 dual rail power supplies on this, 3 level amp. That's quite fancy. We'll check that all this works. We'll check this one's got a big gash in the plastic insulation, but I think it's going to be okay. Just have to tape it back over, but we'll check it. Just going to connect 240 volts to the input of the transformer. This is the sensor tapping on the output.
Okay, I know I keep saying this, but now I'm dead.
And just power it up. Just check all these pins. So we've got here minus 118, 119 volts, plus 119, minus 80, plus 80, minus 40 and plus 40. There we go. Let's check some AC voltage. We're looking for 13 volts on either side of this, and yes, it's there. These skinny wires are undocumented, but I reckon it's the thermal cutout switch. I'll just check the resistance across there and get the meter probes on it. and they're fine. Well, that side's okay. Do the same this side. Plus 40, minus 40, plus 80, minus 80, and plus 120, well nearly, and there's a negative 1. Perfect. Switch this connector out. There we go, 13 volts there, and 13 there. And the thermostat. Perfect. I might as well check that this fan actually works, but I can't see any of the writing on it, and I can't be bothered to undo these screws. We'll check what the manual says. And not too hard to find the fan, says it's 24 volts, but strangely there's a 16 volt capacitor across it, so clearly not supplying it with 16 volts. In fact, to trace this through, this is off a 14.24 volt rail, pretty close to 15. We'll just set this up in the region of.
This is bad.
Well, that's working fine.
This is really fucking bad.
So the chassis hardware is actually okay. Good news. Let's get back to the amplifier boards. Now, they're stuck together just about, so I'm going to take a few screws out and separate them.
I've only got 30 dwarves in the military.
Two modules are separated now, and they're pretty much identical, apart from a little thermal switch on this side. It says on here that the lower module's blown and this is at the top, so it sort of implies this one's okay. We'll have a little check over first. The main place to check is this big row of transistors down here. So we've got the negative half over here and a positive half over there. So on the ends we've got these four smaller devices. These are the MOSFETs and diodes for switching the levels. And the best access from underneath. We'll start from gate to source of this one. Nothing there. From here, yeah, that looks a healthy voltage drop. Then the diode, yep, also good. Same again here. So these six are all in parallel, so only need to measure the one. So we'll go from here to there. That looks healthy, and to the emitter, yes. Now those low voltage drop readings are actually caused by these resistors. These are the emitter resistors that join it all together. So we need to check that there is that low resistance there, otherwise one of these is blown open. So go from the base again, check this one, yeah, it's good, also good, excellent, all the same. Okay, it's the same arrangements on this side, only the polarity is reversed, so we have to use the leads the other way round. So we've got the collector and emitter, they're all good, so check the emitters again. I have to dig the leads in a bit. Yeah, and good, they're good. Same with the level switching hardware here. This diode's good, then we've got the MOSFET.
Idiot.
That's good. That's perfect. Diode again. Also healthy. Finally this MOSFET here. Okay. So the back wall looks good. We'll just check the drivers at the front. So on the negative side we've got an MJE 15033. So this is a PNP device. So we'll just check there. That's good. And there. Excellent. We'll swap the leads over for the other one. And the positive rail is driven with this. This is an MJE 15032, which is NPN. And yeah, looks great. I'll check this fuse whilst I'm here. It's fine. So my gut feeling is this channel's actually good. Now I'll have a poke around this one, but I am expecting trouble. We'll check the level switching MOSFETs. Well, that one looks okay. And the diode.
Oh my god, there's
Yeah,
so many
good.
that hate combat.
Check this one. No shorts. That's good. And this diode. So far so good. Let's check the power transistors, although some of them are already unsoldered, so looks like trouble. And there is shorts everywhere. Well, they'll all measure short because they're all wired in parallel. Shorts on this side as well. Let's check these. That diode looks okay. This MOSFET also looks okay. That's good. Okay, I need to get this PCB off the rest of this, and I've got to take 12 screws out at least. Oh, and these others. And the screws are all buried down there. It's a bit tight.
They're coming for me.
And out you come. I've got this really wide soldering iron tip on here. It's great for getting all the pins unsoldered in one go. Sometimes you need to add a little bit more solder just to get it to flow. Works quicker then. Now they're out of circuit, I can measure them more accurately, find out what's short and what isn't. So this one, yeah, that's completely shorted. Okay, this one is okay, no shorts there. Yeah, a good one. Same here, this is also good. And is this one? Yeah. And finally, this one. Oh, good. So we've got 1, 2, 3, 4 good ones. And one short. And these are the NPN side. Check these again. Yeah, this one's also good. And so is this one. As is this one. Short. We've got a short one there. And finally this one is good. Now the short circuit transistors out there, I'm just going to measure these again, just check none of them are blown open, because quite often these act like fuses. I don't think they're supposed to. And all common to this track here, so just go from there. That's okay. That's okay. Yeah. Well, that's not one of them. They're all good. I've managed to get a whole set of output transistors for it, but I don't know how well they match, so I'm going to check them. I checked the originals with the transistor analyzer and found the gain on the one side is about 84 or so, and this side's about 110. These don't have to match each other, but these groups do. Just going to tip these out. Well, I hope these aren't fakes. I paid enough for them. The markings look good, so we'll see how they measure. Put these leads on any order, it doesn't matter. Well, I'm pleased with that. That's pretty close to the others. It's PNP
Said it was
as
made
well.
of vomit. This one will be easy.
Happy days. Just mark that on the back. And the next one.
This one will be easy.
Bit higher, 137. To speed things up a bit, I've got this transistor base here, so I can just put the clips on here and hopefully they don't short out. Nothing will blow up, mind you. Then I can just push them in nice and quickly. 145.
Yeah, see, that was nothing.
105, bit of a mixture. 124, another good match. 109, lovely. Oh, I didn't mean to take those off. Have to put them back again. The two SC5359s are a bit of a mixed bag. We can see a few different styles of marking on here. $121, okay. Sort of matches the other set, but a bit different from the ones that are in it already. $113, bit more like it. Another one 113. 119. What? 10? Miles out. But then again, it is one that's marked quite differently. Definitely a different batch, without a doubt. We'll check this last one. 126. That's a bit more consistent with the others. Well, there's the entire collection of good transistors, but this one we saw had a gain of 10, which is way out of spec. Should be at least 55 according to the data sheet. I think this is not original. However, normally when I see fake ones, they have some very high gain, like 200 or 300. So, yeah, strange one. The rest of them, however, all look pretty similar. Some are a bit brighter marked than others, but the marking seems spot on. And encouragingly, the date codes are different. It's another giveaway for the fakes. Always use the same batch code. Just flipping them over where I marked the gain, I can now pick 6 of the closest matching ones. This one's a bit easier. We sort of got a bit of middle ground there, so sort of 1, 2, 5, 1, 2, 3, 4, 5, 6. I'll go with those. This is a tougher choice. We need this spread of numbers to be as tight as possible. I'm sort of erring towards 1, 2, 3, 4, 5, 6. Yeah, tricky. Yeah, I'm going to go this way. These transistors aren't made anymore, so I can't really buy a matched batch or anything. So the only way to get them better than that is to keep buying more and more old spares up. That gets expensive. I think these will do. For another level of quality control, I'm just going to put them on the curve trace to see what breakdown voltage I've got. This is one of the originals. It's supposed to be about 230 volts. 50 volts per division across the horizontal, so we've got 100 volts, 150, 200, 250, 300, there it is, that's breakdown voltage. Okay. Put one of the new ones in. So we've got 50, 100, 150, 200, oh, 200 volt breakdown. It's a little bit low, but I think it's alright in this amplifier. To set this for the PNP. I'll invert the display as well. Put one of the originals in, a 2SA 1987. It's got 50 volts, 100, 150, 200, 250. Oh, just over 300 volts to break down. And we'll see how the new ones compare. 50, 100, 150, 200, 250. Oh, they're much better. Nice. Just going to give this heatsink a bit of a clean up first, see if there's any damage on there. Off come the insulators. Ah, to my surprise, look at that, a mirror finish. Well, I can't see any distortion in that really. This is pretty flat. That's good to go. Just going to put some heatsink compound on these first because they've got to be clamped in. I'm just going to run a bead right across here. Then another one here. Then try and spread it out smoothly. Oh, no. Oh, I didn't want to do that. This is messy, messy stuff. I'll just lay them on. Just line the holes up. Just put the clamp on top. pop the screw through there and just screw this on. Not the easiest way to put these together, I have to say. Gently guide the screw into the bottom one. Screw that in. That should improve the sort of integrity of this whole contraption. And the same with these. Oh. Just place me in position again. Just line these up. I just found a problem with these transistors. I don't know how well you can make this out, but this one's sitting low. It's actually thinner, and this one. These are the new ones. These four are the originals. Yeah, they're a shallower case. What's going on? They're supposed to be 5mm thick, and this one is. This is one of the originals. If I get one of the new ones, and they're all the same, 4.5mm thick. And this one-piece clamp isn't going to forgive me for putting a thinner transistor in, so I'm going to have to shim it up. It's got this pack of sill pads in the drawer, and these say they are 0.23mm thick, so 2 of these should do it. Let's check. Yeah, that should work. Hasn't got to be too accurately sized. Just got to punch a hole in this so the screw can come through it. Just put that on there just to build up the height. Oops, same for this one. I think that's levelled them up nicely. Yeah, they're not loose, so that's a good thing. That's looking nice and neat now, so I'm going to put those mica insulators on. Put a bit of heatsink compound on there. And just plop each one on. Let's give these a little bit of a wiggle to distribute the heatsink compound a bit better. But it'll spread under the pressure of the transistor being screwed down. Just put the board back in, hopefully it all lines up properly. I've got a little bit of resistance. I think it's the legs need to be lined up. Let's pop a screw in first. Just press these into the right place. These diodes need to be connected to the heatsink, this thermal paste here. Get a good thermal connection. Then we've got this thermistor, has to go on to this earth tab. Quite a lot going on at once. And same with this side. Can neaten these up a bit now. No, they don't need to be squashed out of the way. Get them off the board really. And do a continuity test from the heatsink to the tabs of these transistors just to make sure that I haven't got any shorts. And I haven't. And nor on that side. Good news. Before I put these modules back in the amplifier, I want to test them on the bench first. Problem is the power supply is quite complicated. 3 different power supplies for the power section, and then there's a plus minus 15 as well. I haven't got enough power supplies to test it properly. I've got 3 power supplies rigged up. I've got this one for the plus and minus 15 volts for the low voltage analog. Then I've got a plus and minus 40 volts for the low voltage power section, and then I've got the medium voltage at plus and minus 55. The medium rail is supposed to be plus or minus 80 volts, and this will go nearly there, but I don't want to put that on in case something goes a bit weird on here, because I don't want to blow this one up. It's only supposed to be doing 60 volts, and I've seen weird things before with oscillations. It's a bit of a rat's nest, to be honest, but hey ho, it's what's got to be done. And for a bit of a sense check, I'm just going to start off with the module that's not being blown up. Assume it works. I've got the low and medium power supplies already on this, the caps are charged up, and so far no trouble. Just going to turn it on here. Well, it's a bit fuzzy, but I reckon that's alright. There's drawing 1/4 amp off each power supply there. That's nice. And no dramas on the medium volt rail. Everything's stable. The oscillation is probably caused by this dodgy grounding I've got going on, but it's the best I could do. I think that's okay. Let's knock all these off. So I'm looking for identical behaviour off this channel, which we just repaired. Fingers crossed. Start with the chassis here, if that's common to the plus and minus 15 volt rail. And this would be the transformer centre tapping, which is the common of the power rails. Not to be confused with chassis ground, it's not the same. This is the minus 40 volt rail, goes on there, L minus. Plus 40 volt goes on L plus. M plus is our plus 55 volt rail. And M minus is a minus 55 volts. Minus 15 volts goes on R85. And plus 15 goes on R82. The input signal comes on pin 2 and 3 this connector. This is a floating input, so it doesn't matter which way around. So we'll connect the signal generator ground to this ground here. I need to link this out. This is the connection for the thermostat in the transformer.
This one kitten is delaying things so much, it's actually super good.
It's the positive and the negative. This black one. Well, it's ready to go. We'll start up charging the caps on the low voltage plus minus 40 volt supply. And we'll do the same with the medium voltage rails. We'll go for broke now. Oh, that's not good. Oh no, what's going on here? Oh no, I think I broke the power supply. Oh. That's another repair. I might do with just one supply rail for now, so I've just reset this to 40 volts and we seem okay. It appears I had the wrong earth lead connected. Oops. You wouldn't think it'd be that fussy, but yeah, apparently it is. Well, similar looking behaviour. It's probably working. We can disconnect all that now. That's knackered my power supply. Bloody thing.
We're closing in.
I'll just shove these two back together. If I recall, they'll only join together this metal shield. Now to turn my attention to these small boards being molested. If you recall the power board, I've got these inrush suppression thermistors wired like this. This is not original at all. A pair of 4 ohm NTCs. Nothing fitted here. If you refer back to the schematics, you'll see where they should be. It says here 1 ohm with diameter 30 mil. Well, this part number here. So I picked up a pair of these SL32s to that spec and let's put them in. Of course, we've got to start by taking the others out. Didn't put up much of a struggle. There's still a bit of metal in here, somewhere. Grab it with a plier so I don't burn my fingers. Just going to get this board a bit up first, it's a little bit grubby.
They're closing in slowly. Okay.
Now I can fit these thermistors in.
Let's good for us for this
I've
to
got long
move
legs on
slower.
this. They'll need trimming.
Spread them out.
That's a bit closer to original now, I should think. Now we've got the front panel board with the potentiometers, which are, oh, a god-awful bodge. I'm not quite sure what they were thinking.
Oh, hey,
there.
gamer bros, how's it
They should
going?
be 4-pin ones, and yeah, I've managed to get some originals. Well, I think they are.
I'm just watching the
And these
slow
are the
decline of
replacements,
my
they're 10K
fortress.
lug pots, and they've got the 4 pins. Interestingly, the 4th pin actually isn't connected to anything, but yeah, I don't know why they like that. The shafts are a bit too long on this, I think. Not that we got any knobs with this, but I do think this needs about 5mm cutting off the end of these. Now to extract these messy pots. How to start this one. They've clearly torn the pads off the back. That might be enough to get it off. And they appear to be stuck somehow. It's all fell apart. Looks like they've only just reached this one, so sort of bend them up out of the way. And one side out. Just see some fine wires on there then, so it was an attempt to connect it, and also on the back. Look, there's sort of glue on top of the solder. Why have they done that? Let's try and clean these holes out nicely. And now I've noticed the power LED is broken off. Oh, it won't come off either. It's actually snapped one leg off. Oh, God. We'll unsolder that as well. I understand this would have been a blue LED. Very trendy. So, I've got a standard 3mm LED. It's not got a flat top, but it goes to the hole. I don't think it matters. So, I'll try and get the legs in. According to that, I've got the cathode at the top, which will be the short leg. I was always told short legs was a negative thing.
Just keep them here for a minute.
I'm going to put the pots in, which fit beautifully. I'm very happy with that. Because the pads and plating have been ripped out of these, I can't solder the pot frame on properly. So what I'm going to do, I'm going to reinforce it with these sort of rivets. So I'm just plonk one over there, and the other one on here. I'm basically going to fill them for the solder. Just fill that right up. Get the tweezers on there just to hold it still. There we go. Well, it seems to have got it. It's still a bodge, but it's a better bodge in my book. So I'm going to check these LEDs work, just using the meter on diode test mode. Puts a small voltage across there. So yeah, yellow's working. In the middle, yeah. And in the bottom, yeah, perfect. Let's check this side as well. Yeah.
Ooh, it's stranded.
Okay, good. We'll put this front panel back in the chassis. Trying to line up the LEDs with the little holes, bit of a fiddle. There we are. Trying to get the nuts to go on straight. It's a very shallow thread. The main switch is supported by these two screws down here, so I can go back in now. The power board can go back in. It's held on 4 screws. I don't know where the holes are though. There they are. Let's get a screw in one corner, not too tight. The other hole's buried behind this massive thermistor. Who put that there? And it's a good time to put the input board on as well. Come on, there you go. JP6 goes to CN6 probably. JP11 probably goes to CN11. Pretty sure this is for the power LED. The wire's just loosely hanging that direction. These will be for the dual 13 volt AC rails there. That's off the one transformer. On the other channel. Yeah, JP71, that'll be the neutral from the main supply.
Okay, well, we cleaned them up yet again.
It's the same for the transformer.
I don't know how much longer I'm going to keep getting away with this, though. No more migrants are showing up. I peaked at 200.
Loose.
It's been downhill from there.
On up a bit, just to tighten it up a bit. Stop it wobbling around. That's better. The transformer primer goes on there. Same on this one. And just in that gap is where the mains comes in from the fuses for the channel 1. Same for channel 2. This is the plug for the cooling fan, came from here. Getting there slowly, but it still looks like spaghetti. I'll drop a cable tie through here. See if we can tidy this mess up a bit. And the magic of a few cable ties is making it look a bit easier to live with this. Just lower the excitement modules in where the bang bangs occur. Plug these into the input board whilst we can still reach it. But I think this is going to be very hard to put together. Same for the other channel. First of all, connect the transformer centre tap in. Because we won't be able to get at this when I put it in, so it's upside down. And the power connector. Sit the right way up. The transformer thermostat goes there. It is indeed needing some jiggling. I think it's about right now. More connectors to go into the front panel, which is from the lower amp and the upper amp. This one's a bit of a nightmare to get at. I've got enough fingers. Same here. Let's make a bit of a clearing, get this thermostat connector in there. Okay. Transformer centre tapping on J4.
Shit.
And the power cable on there. Anything else? Oh, well, what's this? Thermostat. That'll be here. And then we've got the speaker terminals for this one. One there. Positive on there. It's still not fastened down, so they're a bit loose. I'll check there's no cable strapped underneath before I put any screws in. And that's exactly what I want to avoid. There's a red cable there in the screw hole. I see strands of ribbon cable there. Somehow I've got to shove them out of the way. I'll just get my hand in that gap. Yeah, that's got it. I don't know the checks I can do with it out of the chassis now. All I can do is turn it on and let's hope it works. Because it's got this 20 amp IEC connector and I haven't actually got one of these cables in the workshop and I ain't going to give it 20 amps anyway, no way. I'm just going to put some crop clips on here. Chassis ground's actually connected to the oscilloscope and this heatsink now. Plug the dummy load into the speaker connections. And some balanced inputs from the signal generator. Well, that's great, no bangs. Beautiful. Well, there's no smoke now and there's nothing wrong with the lower module. Yeah, now it's warmed up a bit. Half an amp, bit of load on there. Yeah, I see no trouble. I'll try it to me turning it off. Well, the amp's powered down now and I've connected the speaker outputs each to these meters and I measure the DC offset. Strangely, there's half a volt with it turned off and it is discharging, but interesting. Let's give it a whirl. We've got 2.7 millivolts there, 4 millivolts there. This is great. Anything under 10 millivolts is good enough for me. That's fixed electrical problems with this amp, but there's still the casing sort out. Still a bit bashed up. And we don't need this message anymore. Oh, nearly forgot the paper insulator. On with the lid. Oh, there's no hole. And there's quite a gap there. Needs pulling straight. Looks a bit straighter from behind now. Just needs two knobs now. Looks like I'm going to have to make some. that looks a bit smarter. And that'll look great in a 19-inch rack now. And if they can refrain from blowing it up again, that'll be appreciated. Catch you next time.
retraction benches? What the fuck?